All right, guys, I want to make a quick video about this homework. So remember, we're still talking about piecewise functions. So remember that this part right here, so let's do number one, or let's attempt number one at least. This part right here represents the function itself, okay, and this domain represents basically where to graph it. All right, so this right here represents where to graph it. So if I have an x is equal to -3, right, x is less than to -3, that means x is equal to -3 would be this line right here. Now, this line doesn't really appear on the graph, but I'm just trying to make an idea out of it, right? So if I were to graph 2x plus 10, yes, of course, you can start at the y-intercept of 10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Of course, you can start here. All right, and then the slope is up 2 over 1, but since I can't keep going that one, I can also go down 2 over 1. Now, the thing to understand is that right here, that's where you're going to start actually graphing, meaning do not graph anything. All right, so we're going to say this one's red so we don't get that confused later. Right, that's what that would look like. Right, but again, notice that I'm not drawing the line past this, right? So you're only going to draw this if x is less than -3. So x is less than -3 is actually the left side, right, of this dotted line that I have right here. Now on the right side of the line, and I'm going to graph the line -2x minus 1, right? So I'll tell you what, I'll let you do that part, all right? So you're just going to graph that, but remember, do not graph that graph past, let's see, 6, 7, 5. Do not graph past this line over here, past this line. Do not graph that past that line. All right, so again, you're going to graph -2x minus 1. Remember, y-intercept is of -1. And you're going to graph that all the way until you hit that vertical dotted line that I wrote there. All right, so let's move on to number 2. Now, number 2, I may do a little bit more just because it's been a while since you graphed some of these, right? So remember, you're going to graph x squared. All right, so let's do the colors here again. Or -x squared plus 8 on the left side of the graph. You're going to graph, let's see, so I'm going to draw a dotted line here. So this part right here, you're going to just graph it on the left side of 0 because x is less than 0. And then you're going to graph this -3x minus 7. This -3x minus 7. You're going to graph that over here between 0 and 4. So the domain, when you read that domain, notice that I didn't even say 0 is less than or equal to x, which is less than 4. Really what I'm saying is in between 0 and 4. That, I mean, truly is not quite in between because it doesn't include 4. Or excuse me, 0 is included, but that's not really going to matter to you. All right, and then finally, this square root function, you're going to graph that to the right of this, all right, which is, they kind of wrote that weird, but you can write this as x is greater than or equal to 4. So again, this would be the right side, if you will, of the graph. The middle part is going to be the middle. And then the left part, well, that's going to be the left. All right, so let's use that blue marker first to write this. Now, you may not remember, but -x squared plus 8, all right, the parent function is x squared. All right, so we would write, I'm going to write this 1 so you can see it. So again, this graph, this line, excuse me, this line is not, or this function is just the parent function, right? So I'm gonna come up with some points for that parent function, like 0, 0. Right, remember, all I'm doing is I'm squaring x values. 1, 1, 2, 4. I'm also gonna pick -1. If I square -1, I get a +1. If I square -2, I get a +4 also. All right, so what this function means is that this is going to be up 8. All right, so I'm going to go from the origin up 8. And then notice that because the domain is not equal to 0, it's not equal to 0, I'm going to write an open dot like that. I'm going to draw an open dot, that is. So now, remember that negative means you reflect over the x-axis, right? It's a reflection, so therefore I'm going to be going down. So all of these, you would multiply all of these times a negative. So I'm actually including a lot of stuff that we've done in the past, but I get it if this was not something you remember. So if you look at it, right, I'm only going to graph on the left side. And I'm pretending like that point is not 0, 0. I'm going to pretend that point is 0, 0. Right, and from there, I'm just graphing essentially 1, -1, 2, -4. And I could also graph 3, -9, or excuse me, -3, -9. But, I mean, I guess I can, but that's really all I need. It's just a sketch. All right, so that's what that graph would look like. Now, the middle part is a little bit easier. All right, the y-intercept is 7. So let's switch that color to red. All right, so the y-intercept is 7, which is right here. And it is equal to, notice that this is equal to right here. So I'm going to draw a solid point. And then the slope is -3. So I'm going to go down 3 over 1, down 3 over 1, down 3 over 1, until I get to this other dotted line, which notice it is not equal to 4. So therefore, this next point is going to be an open dot. And then I'm going to connect them. All right. Now, last but not least, the one that you may not remember, okay, is this one right here. So this one right here is a very specific way to graph this, and we'll talk about what that means here in a minute. Remember, the -4 means you're going to go to the right. That's right. I said to the right, 4, and that's going to be up 1, right? So if I go to the right 4 and up 1, that would actually put me about right here. And to know what else to graph, well, you have to come up with the points for the parent function y is equal to the square root of x. Right, so think of some numbers so you can take the square root of easily, like 0. The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and so on and so forth. So I'm going to pretend like that point again is 0, 0. And I'm going to say that's 1, 1, and then 4, 2 would be right here. All right, so that would be what that would look like, okay? So again, really all you need to do is see if you can do that one. Now, if you can't, I would suggest, obviously, this is really up to you to try to redo number 2 to see if you can do it on your own. Is this not enough for you to see me do it? It's one thing for you to see me do it, and it's another thing for you to do it, right? Let's look at this number 4, right? And I'll let you do number 3 on your own now. Number 4, we have to figure out, notice that we have, let me switch to red here. All right, notice that we have 3 pieces, right? Hence the name piecewise defined functions. So I'm going to have 3 functions here. All right. The first function on the left side, so always start on the left side, is that one. Notice that this right here, if you look at this problem or this table that I had here originally, this basically follows those points except for all the y values are positive. So what I'm trying to tell you is this is a quadratic, right? And that quadratic can have the form of this if it's in vertex form, right? So this is x minus h plus k squared. I don't know if you remember that, where hk is the vertex, but essentially that tells you stretch, which is not going to be stretch. It also tells you if it's reflected, if it's negative. This tells you it's going to go to the h units, right or left, essentially. And finally, this k value is up or down. Up or down. All right, so here's what I'm trying to tell you. Just by looking at this vertex right here, I know what the function is. Notice that vertex, I went 5 to the left, which is going to be x plus 5. Remember, that's always the opposite, squared. And then I went down 4, so this would be minus 4. So that's how you write that part. Now, it is not being reflected, so therefore you don't have a negative there, and it also is not being stretched. And the reason that I know that, well, I guess you can pick a point and figure that out, but the other way to do it is that this distance right here, 1, 2, and up 4, that means you're not reflected because it's exactly like the parent function, right? Or even this first one, okay? Anyway, so for this one, the domain, look at it. I am starting at -5 and going left, so this would be x is less than, I guess I need to write an if x is less than, or that's it, less than -5. And it's only less than, not equal to, because I have an open dot right there. All right. Next up, this middle graph. This is another quadratic, right? And that quadratic, let's see, if I just know the vertex, let's see, I went to the right 5, so this would be almost the same. It would be x plus 5 squared, except for I went up 4. So this almost has the same identical function, except for my domain. It's in between -5 and -3. Now notice that on -5, let me make sure. Yeah, -5, you have a solid dot, which means that -5 is less than or equal to x, which is less than -3. You got -3 because you have an open dot, so it's not equal to. Then finally, this line right here, this line, probably the easiest thing you can do is look at the y-intercept, right? This is going to follow the y is equal mx plus b form. So the y-intercept is -1. Looks like the slope is down 1 over 2. So it looks like this would be -1/2 x minus 1. Let me make double sure here. Yep, that looks like that's what that is. Negative slope, yes. All right, so we're all good. And this would be if x, and notice that this right side of the graph would be if x is greater than -3, greater than or equal to -3. All right, so that's it for that. See if you can do the same. Remember, this is a parabola, right? This is a parabola. There's the vertex. See if you can figure that out. There's only 2 pieces to this one. Then finally, number 5. Not going to get too far into it, but this is probably easier than what you'll think. When it talks about that Kayla works, she gets paid $12 an hour, that's a linear function where x, for example, you can call it h if you like. This would be the amount of hours she works. Okay, so basically, as you probably know, if you work, right, you multiply the amount of hours that you have times what you could pay per hour. So that's how she's going to figure that out, but she only gets paid this if her hours that she works is between 0 and 40, right? And if she works over that, well, she's going to get paid $18 an hour. So what would you put here? All right, so you need to write one more function right there. All right, that is all for today. Hopefully that'll help, and let me know if you have any questions when I see you.